Hello friends, welcome back. Hope you're all doing well. Today we've got some interesting updates to share with you. Let's begin with the SmallSat Symposium panel advising the small satellite sector to prepare their strategy for keeping up with Starship. On the 7th of February 2023, the panelists at SmallSat Symposium stated that presently keeping in view the Starship developments, it's now necessary for small satellite manufacturers to prepare themselves for the advent of rideshare flights on the Starship and Super Heavy launch vehicle in the near future. Abhishek Tripathi, the Mission Operations Director at University of California, Berkeley Space Sciences Laboratory, also the former SpaceX Dragonflight Reliability Director, stated that if you are not preparing for how you're going to launch your product on Starship and how you're going to change your business model to work with Starship, you're going to be in trouble. He also mentioned that companies need to make changes in the business model in such a way that they can take good advantage of the rather inexpensive rideshare flight that Starship is expected to provide. If that means that I need to partner with a space tug to get my final orbit, okay, let me go and talk to a bunch of space tech companies, Tripathi said. Other panelists also agreed with the fact. Fletcher Franklin, Bryce Tech's senior program manager, said, "When the first transporter mission started going, the number of small sats launched on small launchers just fell off a cliff." However, he also gave a hope for small launcher companies, stating that, "I see the small launchers still proving out capacity. Certainly, companies with a lot of tenacity will keep driving the small launch activity for several years. Moreover, thinking of Starship rideshare program dismissing of small launchers is certainly not going to happen soon, as the spacecraft in question is still in its development stage and will take a good deal of time to become commercially available. Presently, SpaceX teams have already completed full-stack fueling and wet dress rehearsal already at the end of January. Now they only have to do 33 engine static fire of the Super Heavy Raptor engines to become launch-ready. And according to Musk, Starship will head to launch in March if all goes right." Musk tweeted, "If remaining tests go well, we will attempt a Starship launch next month." In a follow-up tweet, he wrote, "Success is far from certain, but excitement is guaranteed." As of early February 9th, SpaceX will attempt a static fire test of every one of the 33 engines in its Starship booster. If successful, the test could allow the company to attempt an orbital launch a month later. Gwynne Shotwell, President and Chief Operating Officer of SpaceX, made the announcement during a speech at the Federal Aviation Administration Commercial Space Transportation Conference in this city on February 8th. This test will be the last significant technical achievement before the vehicle makes its first orbital launch attempt. As per Shotwell, "Tomorrow is a big day for SpaceX. We're going to attempt a 33-engine static fire booster test for Starship," she said. "It's really the final ground test that we can do before we light them up and go. The static fire test will mark the initial ignition of each of the 33 Raptor engines in the Super Heavy booster. When 14 engines ignited simultaneously in a booster, some pad damage was caused." After a presentation, Shotwell spoke with reporters and expressed her optimism that the company's modification will shield the pads from harm caused by the upcoming, more intense test. For a Starship launch from SpaceX's Boca Chica, Texas test facility, an FAA launch license that's still in the works will be necessary, which entails putting at least some of the FAA's recommended mitigations into practice. Later, during a discussion with reporters, Shotwell referred to the 100-flight milestone as a great milestone, but she implied that it wasn't necessary. "I would love to do hundreds before," she said. "I think that would be a great goal, and it's quite possible that we could do that." She stated that the company's objective for this year is 100 Falcon launches. "If we can do 100 flights of Falcon this year, I'd love to be able to do 100 flights of Starship next year. I don't think we will do 100 flights of Starship next year, but maybe 2025 we'll do 100 flights." First, she said SpaceX needed to get Starship to orbit as soon as it can. We'll go for a test flight, and we'll learn from the test flight, and we'll do more test flights. The real goal is not to blow up the launch pad. That's success. So, keeping in mind that Starship is still in the development stage, and pricing is also not known for probable Starship rideshare flights, it's a bit difficult to predict Starship's impact on the launch market, specifically on the grounds of pricing. Now, in our last update, SpaceX Raptor engine is going to have a competitor from Stoke Space. Recently, Stoke Space, a Seattle-based aerospace startup company, has revealed their plans to develop an efficient rocket engine that will be similar in technology while comparing to the Raptor engines that SpaceX developed for their Starship rocket. On the 7th of February, Stoke revealed that they've already begun testing a crucial component of their full-flow staged combustion engine for their fully reusable Stoke rocket. Till now, SpaceX is the only company to have successfully developed a full-flow staged combustion engine through Raptor, a great feat in rocket engine science. And presently, Stoke aims for it and is significantly on the way to develop it. If they can do it successfully, then they can become a competitor of Raptor at that full-flow technology. Now, what is a full-flow staged combustion technique? In all rockets, specifically the most powerful and efficient chemical rocket engines, need to consume huge volumes of propellant in a short amount of time without destroying the launch vehicle itself. And to create pressure and spin the pumps that are needed to feed that propellant into the main combustion chamber, engines often burn a small amount of propellant in a separate gas generator or preburner. But those gas generator engines have to vent that exhaust overboard, which makes it less complex in design with reduced efficiency. In staged combustion engines, preburners are used to create gas that pumps the liquid propellant, and later exhaust gas is injected into the main combustion chamber. But in a full-flow staged combustion, the engines have two separate pumps and preburners for oxidizer and fuel. These engines turn all of their propellant into gas before injecting it into the combustion chamber. That hot gas increases the heat of combustion and the pressure inside the combustion chamber, ensuring that virtually all the propellant that flows through the engine is combusted and turned into thrust as efficiently as possible. But in doing so, there are chances that virtually everything imaginable will spontaneously combust under that tremendous heat and pressure generated, making it difficult to achieve. Only custom-built complex alloy structures can withstand such conditions, and Stoke is after it. The Stoke Space was founded in 2019 by CEO and co-founder Andy Lapsa. Despite being a startup with very limited workforce and resources, they built a test facility for their rocket engines, as well as developed and tested their first full-scale rocket engine. And that helped them to secure their first funding of $9.1 million almost 3 years ago. Later, they also received funding of $65 million that will also become handy for their development of a fully reusable Stoke rocket that can deliver a 1,650 kilogram payload to LEO at a very cheap price tag. Other than making it fully reusable, Stoke Space incorporated several exotic technologies into that rocket. One of them is the recoverable booster with 7 full-flow staged combustion engines, as well as recoverable upper stage powered by single engine with integral fairing. The first full-flow booster engine Stoke Space ever attempts to build will be a reusable full-flow staged combustion engine powered by liquid methane and liquid oxygen. The recovery of Stoke's booster will be more or less the same with SpaceX's Falcon boosters, that guiding the booster using grid fins as well as descending on landing legs. Stoke Space's planning of upper stage propulsion is quite unique. According to reports, though having a single engine, a large pump will feed propellant to up to 30 combustion chambers distributed around the rim of its heat shield. The exhaust coming from those 30 chambers will expand and partially push against the heat shield of that stage, which in turn will increase the efficiency of the upper stage. Interestingly, Stoke Space has started to work with the upper stage first back in 2022 and has completed dozens of static fire tests. Report says that Stoke plans to conduct hop tests with that prototype if it passes the qualification testing successfully. And now they've started working on the booster engine too. Thanks for watching. Please subscribe for more videos like this. Hit the like button if you find the video interesting, and kindly provide your valuable feedback in the comment section. This will help us to improve.